Good morning, everyone. This is Michael Dahl speaking on episode number 17 on LC mass specs. We would touch on fundamentals, instrumentation, and applications. We welcome LCGC International Magazine as our channel collaborator. Here's the agenda comprising on three different parts. First one is fundamental, covering terminology, concepts, mass range, and resolution. Second, instrumentation, speak on ion source, fragmentation, mass analyzer, detector, and different types of mass specs. Finally, perspective and application, focusing on pharmaceutical and biopharmaceutical application. We'd like to acknowledge major contribution from Dr. Christine Go of AppV. Some of the material in this video come from this particular chapter in the book published in 2017, which is chapter 6. What is mass spec or mass spectrometer? Mass spec is an instrument offering unprecedented speed, sensitivity, and specificity. Mass specs separate ion by their mass to charge ratio, or m/z, in a high vacuum. A mass spectrometer consists of three major components. First, an ion source, second, mass analyzer, and also a detector system. LC mass spec is liquid chromatography coupled to a mass spec. It's amenable to a wide range of involatile compounds, including those with high molecular weights and also different polarity. Some of the examples are ions, proteins, drugs, natural product, and biomolecule. So here is a schematic of the HPLC coupled to a mass spec consisting of three different major parts. Here's a listing of basic terminology and concepts in mass spectrometry. We would cover these in a little more detail later on, starting from resolution. There's two types of mass, nominal mass and also average mass error and mass accuracy, mass defects, and adduct and cluster ions. Some example of mass resolution of R, which is equivalent to another term called resolving power. Many of the mass specs are low resolution or having a unit mass resolution, such as quadruple. Later we would define what it is. And the way you measure resolution is by the mass over the full width of half height. Seeing that is the mass divided by this width half height. You can see that this is for low resolution is typically a unit resolution. Versus high resolution such as time of flight, one can see that the resolution is quite a bit finer with a much higher resolving power. This slide talks about different element type based on the isotopic abundances or the natural abundances. There are three different categories, called A elements, A+1 elements, and A+2 elements. So A element is element with only one natural isotope, such as in the list here, hydrogen, fluorine, phosphorus, and iodine, where there's 100% natural abundance on these elements. Versus A+1 elements, where they have A+1 with some natural abundances, such as carbon and nitrogen. Versus A+2, there's a few common ion, oxygen, silica, sulfur, chlorine, and bromine. This slide describes common adduct ions observed in electrospray ionization, ESI, which we will define a bit later. Uh, in the positive ion electrospray, one can see very common to get a protonated molecule or adducts with alkaline metals such as sodium or potassium, ammonium adducts, adduct with solvent, and also protonated dimer formed at a higher concentration. And some of these are negative ion in electrospray are shown here. There's two types of common ionization technique, with ESI being the most prominent, and also APCI. ESI stands for electrospray ionization. ESI is a soft ionization technique, very much in use for biologics. It's a dominant mode used in 80 to 90% of all LC applications. APCI stands for atmospheric pressure chemical ionization, more compatible to low or medium polarity compound. However, the upper mass range is limited. And some descriptor for the ESI processes, where the HPLC effluent go through a nebulizing process, which create a charge spray, and a counterflow of heated nitrogen drying gas shrinks the charge droplets, and as the droplet shrinks, Coulombic efficient create analyte ions in the gas phase. We generally describe electrospray as a liquid phase ionization. In APCI, it's a gas phase ionization technique using a high voltage discharge needle, corona discharge needle, to ionize the molecules. This slide shows some common mass analyzer, uh, starting with single quad, triple quad, uh, a time of flight, ion trap, OB trap, and FT ICR, right? So the three on top are low resolution mass spec. Most common is a single quadruple, and then you have the ion trap, which can fragment ions, and a triple quad where you have a three quadruple lined up together. The middle one is really not a quadruple; it's kind of a collision chamber. This is actually the gold standard for trace assays, quantification. Triple quads becoming quite important. In the high resolution arena, we have the time of flight, OB trap made by Thermo Fisher Scientific, and Fourier transform ion cyclotron to resonance. This is very expensive, so this is rather uncommon. Just very briefly describe fragmentation. On the triple side, there are different type of precursor ion going to product ion, which can allow us to quantitate very selectively with high degree of accuracy. And the ion trap is capable of ms to the nth power, to up to like 10th fragmentation power. However, most, for all intents and purposes, probably the third power is more realistic. Here are some example of common mass detector. Most of them, the most common one is electron multiplier. There are also Faraday cups. This one is perhaps the most common one, and other type of mass detectors. In this schematic supplied by Agilent Technology, describe the process of ESI in a single quad, right? Here we have HPLC inlet with the LC element, and there's inside here is a nebulizer with a counter ion of heated nitrogen, kind of desolvating the solvent ions into the vacuum, into a rough vacuum pump. and ions are attracted into these capillary tubes, which are typically negative charge for positive ionization. The pressure from the eluent is 1 atmospheric. The pressure inside the single quad is about 10 to the minus fifth torr, so it's a high vacuum. While pressure for other mass spectrometers with high resolution is actually much higher, much lower. And here is the ionic optics, and here's the quadrupole, which is kind of a filter, a mass filter, scanning by changing the quadrupole voltage. This slide summarizes some perspective on LC mass spec, bringing everything together in a snapshot. We said that the LC mass spec allow very sensitive and specific quantifications, and also identification and structure elucidation. You know, the level of speed and sensitivity is unprecedented. A different type is single quad for general ID or confirmation for mass, ion trap for structure elucidation, triple quad, which is the gold standard in trace quantitation, and particularly in bioanalytical assays. And for high resolution mass spec, it's time of flights for accurate mass, OB trap, and also OP trap. Some of the mass spec can exist as a hybrid or tribrid, such as a QTOF, right, quadrupole connected to a time of flight, and some of the OB trap could exist as a tribrid. What some of the most prominent pharmaceutical applications for identification, structure elucidation, trace analysis, bioanalytical assays. For instance, for protein identification, typically instead of using sequencing, we do a de novo sequencing using LC-MS from a tryptic digest, such as a QTOF or an OB trap. Also, applications of proteomic and all kind of biochemical research. One often say that mass spec in conjunction with HPLC is actually transforming research in life science, one of the most important and most powerful analytical technique in existence. Here in this table describes some of the prominent scan modes available in quadrupoles, so both single quad and triple quad. So quadrupole, you can do a full scan mode, and also you can do a single ion monitoring mode, which is higher sensitivity and selectivity. Triple quad, the most prominent one is called SRM, standing for selected reaction monitoring, used in most of the trace quantification. This big table summarizes the performance of different type of mass analyzer, or the common one mentioned before, quadrupole, ion trap, Tuft, OB trap, and FTICR, right? So a big table summarizing all the performance in terms of resolving powers, mass accuracy, mass range, scan rate, also linear dynamic range, and cost. Some prominent examples shown here. First one is Waters QD8 2 mass detector, a very low cost and actually quite powerful favorite for a chromatographer without a lot of expertise in mass spec. Very easy to use. Also, this is one of the top Agilent LC QTOF shown here. Yeah, here is the flight tube with the with the ion being this is the time of flight evacuate chamber with under very high vacuum. SciEx turned out to be the 7500 is one of the most popular gold standard in bioanalytical assay. And here is thermal fusion Loomis tribrid. Next slide shows the tribrid from Thermo Fisher Scientific. This is the Loomis, and it actually consists of three different mass analyzers, starting from a quadrupole, and in the middle is a OB trap for very high resolution, and the end is a ion trap. This is actually a linear ion trap, a dual pressure linear ion trap. Great for structure elucidation and peptide mapping. This slide summarizes the major mass spec manufacturer and their associated analyzers. So whole list of manufacturer. The one highlighted in red is likely the most common or more popular one. So starting from Agilent, SciAx, Thermo Fisher Scientific, and Waters. And here is the different type that they support and the operating software that is available. Here is a few highlight on the tutorial on some basic concepts. Nominal molecular weight versus the average molecular weight. Just a note from Christine Gold that one never used this value in mass spectrometry. One always used the exact mass in the ID and other applications. A clarification and a calculation example for mass accuracy. Mass accuracy is different between the measured accurate mass and the calculated exact mass, right? So that gives you mass accuracy, typically measured in ppms. Here's one example of this particular molecule. So one get a mass accuracy of minus 1.2 ppm. Another example of this drug molecule, which is an AKT inhibitor, getting a measurement of 2.6 ppm. Here's my summary and conclusion. We spoke about the fundamentals, terminology concepts. We summarized the instrument, the ion source, mass analyzer, and mass detector, and the different type of mass spec, spanning from single quad to OB trapped. And perspective, we mentioned about the overall perspective and application in pharmaceutical and biopharmaceutical industry. On that note, we completed episode number 17 of LC Mass Spec. We talked about fundamental instrumentation, perspective, and application. Please, we encourage you to subscribe for this video channel for future videos on HPLC fundamentals. And we thank you for your attendance.